Hello everyone, and thank you for joining today's webinar. My name is Nate, and I am a sales engineer at RISA. First, a few housekeeping items. Please be aware you can connect to the audio using your computer, or even by calling in. Also, please use the Q&A chat box to ask any questions you have. We have other engineers standing by to assist. Today, I'm going to be working within Adapt Builder, where I will focus on exploring the key features of the program. Specifically, we will be looking at several items that I feel define Adapt Builder, as well as what makes it the most powerful PT design software available. I will first begin showing how you can quickly create geometry within the program using a DWG. We will then go over the general process for investigating an existing structure, as well as designing a new one. We will then transition from single level to multi-level mode within the program, followed by a discussion on our patented tributary load takedown feature. You will also learn about usage cases and as an example, how they are useful in the design of a foundation. We will then finish off by looking at a case study project done by Lyra, which will soon be featured on our website, as well as going over the new features in version 20. My goal is that by the end of this webinar, you will understand why Adapt Builder is a robust tool that you should utilize for all your concrete and post-tension concrete buildings. So let's go ahead and open up Builder. Right now I have Floor Pro and the PT module enabled. At the top, you can see our ribbon-based UI system, and it's laid out in a logical fashion from left to right in the typical order at which you would progress through the creation and design of a model. This makes Builder a real easy tool to learn for users that have never used the program before. In the middle, we have our model space. This is where we're going to see the geometry as we create it, as well as some of the results as we run through the analysis and the design. On the left side is our new property grid feature. This makes it a lot easier to change individual components, their properties and such, as well as a group of components all in one go. At the bottom, we have our quick access toolbar, which has a lot of useful tools that you'll be constantly using throughout the modeling and design process. For example, we have all of our snap tools here on the left, as well as some different views that we can toggle between, and even the ability to display and remove different items from the view. The way a lot of our current users use Adapt Builder to create their models is by importing a DWG. So I'm going to show that now. So we go to File, Import, DWG. I have this DWG set aside right here. You can actually download this single level tutorial DWG from our website. And there's a guide to show you how to create the model geometry and kind of walk you through what I'm going to show you today. So let's click Open. Then we're prompted with a couple of options regarding this DWG. We're going to want to calibrate this drawing so that the dimensions within Builder match the actual dimensions of our CAD drawing. We'd also have the ability to move this CAD drawing in the XY position, say if we had existing geometry in the model. We could also insert this DWG at a specific Z position in our model. For example, if we had a multi-level building that has a change in geometry from one level to the next. We also have the ability to assign this CAD file to a CAD group, and we can be really smart about how we do this. I typically like to name this based off of today's date. This way I know that I imported this CAD on this date, and then if I have a new CAD drawing that has changes later on and I import that, I can date it again, and then I know which one is new, which one is old, in case I need to switch between them. So let's click OK. And you can see our line work has been brought in, excuse me. Now, this project appears to have very regular geometry, and I could technically model it in Adapt PTRC. However, I prefer to use Adapt Builder because I'll be able to more closely capture the actual building behavior since this is a finite element program. Now, at the top, you can see the program is prompting us to enter the start point of a calibration line. I like to pick a nice clean dimension within the model or on our CAD drawing. So I'm going to turn on some of my snap tools. And for example, we're going to grab this 30-foot dimension here and click our second point. You can see it's asking us to enter the distance between those 2 points. And this is in feet. So I'll type in 30 feet and click OK. Now it doesn't look like anything has really happened here. And we can verify that the model is actually calibrated by going to our Home tab and using this measuring tool here. If I just grab another dimension, for example, this 25-foot span, you can see it's reporting 25 feet. So it looks like everything's good. So I'll clear that real quick. So what's really cool about our DWG import is not only did it grab the CAD line work, but if I double click this slab edge, for example, and click the properties, you can see that it actually imported the layers from our CAD file. Now this is important for streamlining the ability to either select different components in our CAD file, assuming you've assigned them appropriately to layers, as well as toggle different aspects of your CAD line work on and off. So what I could do is go over to the modeling tab, and in the add structural components, I could start adding a slab using the add slab button and using our snap tools and simply just snap to our CAD work. However, there's something special about this DWG, which you can do in preparing your DWGs for import. And that's when I click the slab edge, you'll notice that it's a closed polyline. And what that allows me to do is actually use this transform tool over here. So when I click transform, it's going to create the slab automatically for me. Notice that it grabbed each point and vertex of where there is a jog in the slab. And so if this was a very big slab with a lot of jogs in it, I could do this very quickly. Now I can do the same thing with my walls, for example. If I just hold the control key, I can click these other walls. And since this is a compound wall in the core area here, we're not going to want to use the transform single wall. We're going to want to transform compound walls. So I'll click that. Now it looks like the program misinterpreted a little bit here, but it's very easy to just click, press delete, and it's done. Let's do the same thing with these openings here. Just hold the control key, transform openings. And there we have most of our geometry. But we still need to add our columns. And I could go through and hold the control key and click each individual column, but that's a little tedious. And as I said earlier, the CAD line, the layers from our CAD file were imported. And so we're going to utilize that now. So if I go over to our Home tab, I can actually select by layer. And the columns are on the tutorial column layer. So if I select that, click OK, you can see all the columns are selected. And then I can go back over to our modeling tab and I can quickly select transform column. And notice that it actually grabbed each dimension of the column as well and mapped them appropriately. So there we've created our geometry. Now we're not going to need our CAD drawing anymore. So if I go over to the visibility tab, I can go into our group library and notice here is that conveniently named CAD file or CAD group that we had imported at the beginning. I can click that light bulb, click OK, and the CAD file is away. If we go into an isometric view, you can see our geometry in a much better angle. We can even see a rendered view, which will open it in a new window. We can spin this around and take a look. I think everything looks good. So say you brought this CAD file in and you then realize, oh, there was an error. You know, Builder allows you to easily manipulate components even without your CAD drawing. So for example, let's say this column is not where it's supposed to be. I can simply select it and I can move it just by clicking. And you can see our dynamic dimensioning lines showing where it's going to be moved. And I could just move it simply as that. I'm going to undo that. The other way we could do it is if I select the column, you can see there are global coordinates for this column. I could change these, or if I wanted to move them relative to the column's current location, I can go into my Modify tab, and I can translate this by coordinates. So for example, let's say, hey, this column needs to be actually 3 feet to the left. And if you watch carefully, you'll watch this column move to the left, just like that. I'm going to keep it where it was, but just wanted to show you the flexibility in being able to manipulate the model even after the CAD work has been imported. Now, I was saying that the UI is laid out in a logical fashion from left to right, but I went ahead and skipped the criteria because, let's be honest, modeling is a lot of fun. But let's go ahead and get back into the criteria tab. And this is where we can actually set up the different material properties within our model, as well as our design criteria. So let's go ahead and look at the concrete material. And in here, you can see we can specify things such as unit weight. We could even specify a unit price if we want the program to do a quantity takeoff for us. We can specify the concrete strength and things such as modulus velocity and factors. What's really cool with Builder is if you actually change your modulus, or sorry, your concrete strength, it will update the modulus elasticity for you. I'm going to keep the 4,000 PSI default. Now, let's say we have different concrete materials in our structure. For example, sometimes your columns and walls are going to have a higher strength concrete. We can do that by simply clicking Add. We could even name this something if we wanted to. For example, let's say this is walls. And we could change it here very quickly. Click OK. And if we wanted to, we could select by type again, similar in the Home tab, or we could individually click these and assign them the different material stiffness. And that's right here. I'm just going to stick with concrete one. So let's go back in there and we can remove this concrete material. If we move over to our rebar tab, you can see the different material properties for our reinforcement, simply our yield stress and our modulus of elasticity. You could also specify a unit price here if you would like, in case you want to leverage that quantity takeoff amount as well. We also have one for our post-tension cables. Here you have ultimate strength, yield stress, and modulus elasticity. Again, there's that unit price. You also have the ability to add steel fiber mixes to this. Now notice, when I click that, it just opens up the concrete material window again. And here you can add a draw mix steel fiber reinforced concrete mix. You can specify the fiber material type, as well as dosage, and the other factors associated with that. Moving into the design criteria section, these are all broken out individually, but they all open in the same window. So for example, let's just click the design code. And you can see all these different options listed up here in these tabs. Now, we're going to go ahead and change this to ACI 2019, which is new to version 20. And we'd also have the ability to change other aspects of our design criteria, such as our shear design options, roundup amounts for our rebar, the preferred lengths that we want, our default covers, our analysis design options, which there's a lot of power in this window here. And we're going to get into the difference between single level and multi-level at a later point. But right now, you can see in single level, we're assuming a roller support and rotationally fixed condition at the bottoms of our columns. And when we switch over to multi-level mode, we're going to assume a fixed in position and rotationally fixed condition for our entire structure. And you could go ahead and change this if you wanted to assume different conditions for the different analysis modes. We also have tendon height defaults, preferred reinforcement sizes, and you can even specify your allowable stresses. This is grabbed from the design code that we had picked, and they're unique to these different slab criteria. For example, we're going to have different factors for a two-way slab versus a one-way slab, and for beams as well. So the information for each of these is unique, especially, for example, the rebar amounts. So if you wanted to specify a different rebar for top and bottoms for your beams, you could do that. here. But I'm going to keep the defaults. So we did our modeling. We went back to our criteria because I skipped it. But now the next logical step would be loading. Now we can set up load cases. And it's simple to just add additional load cases. Say if we wanted to have a snow load here, we could do that. Or a roof live load or any other load that you wanted to specify. I'm just going to stick with the dead and live load to keep it simple. So I'll go ahead and delete this. We'll click OK. We can also set up different load combinations in this window. These are default load combinations based off of the design code that we had picked, but it's super easy to add additional load combinations, such as your service sustained loads, service total load, strength, initial crack deflections, combinations that you wouldn't want the program to check, but you want to get results for, the long-term deflections, and even P-delta effects or P-delta load combinations. We could add, for example, a long-term load combination here, or long-term deflection load combination, and specify our creep and shrinkage factor. Notice that that adds it there. And it's easy to change these factors in this Excel spreadsheet type deal. You just simply click and you can just change the factor like so. I'll go ahead and keep the defaults. We'll click OK. So there we have our load combinations, our load cases. Let's go ahead and add some loading to this building. I can quickly add patch loads by simply selecting my slab region and using our patch load wizard. For example, I'm going to add 10 PSF dead load. Pay attention to the units here. This will trip up some of our users on occasion. So it's important to note that. So there's 10 PSF dead load. We'll go ahead and add some live load as well. We'll do 40 PSF. Click create. Now it doesn't look like anything's happened, but if I go in an isometric view, you can see the loading here. I can select each one of these loadings, and I can see the magnitude and the other information about this load. Now, your model might start to get a little cluttered, and this is where you can use the green eyeglasses down here. And you have the ability to toggle the display of different elements. So for example, I want to turn off my loads. So I'll do that. Now, before I leave this window, I like to do or set up what's called a default display. And this is really powerful to help you quickly reset the display of your model because things are going to be showing up, things are going to be removed, and you want to kind of go back to this base point of how you view things. And I typically like to have my geometry turned on. And what you need to do is click Save as Default. So once that's saved as default, let's say we have a bunch of stuff on our structure, like these loads, for example. We could have tendons and rebar and all this other stuff. And if we wanted to clear the display, and in my case, go back to the geometry, I simply click this default display button, and it puts it back to the default. Let's change the view back to top down. So now that we've set up our base model, Adapt Builder gives us the flexibility to proceed with two different routes. One, we can either proceed in determining a PT and rebar design as if this was a new structure, or two, we can assume that this is an existing structure and we need to investigate it for capacity. So for example, let's assume we have some additional load in this area of our structure. Now, before I start adding this additional loading, I'm going to assume that this is a PT structure, which will just ultimately complicate it a little bit more. If this was a traditionally reinforced concrete structure, the procedure would be exactly the same, and in fact, a little bit easier because you wouldn't have to add in your PT. So let's go ahead and assume that we're going to check this structure with, say, they're adding some additional loading. So let's add a couple of point loads in this area. Maybe we'll add a 1.5 kip load, dead load in this area. We'll add a couple. I'm just going to arbitrarily pick them in here, like so. And I could move these, or if I knew the exact location relative to this column, I could use that modify option in here and translate by coordinates. Say, for example, it's 4 feet in the X direction, but -3 in the Y based off of this column location, and I could move it. Or if you needed to import additional CAD to map out this area, you could do that. So with this being an existing structure, we're going to have to model what is currently in that building. So going back to our ribbon, you can see the next tab is going to be our tendons. So let's go ahead and add our tendons. I'm just going to assume a couple of tendons in this area, and you would actually know the exact quantities for the PT because it would be an as-built condition. So I'm going to take a stab at what I think is going to be the appropriate amount for this slab to meet pre-compression, but I might be wrong. So let's add this tendon here. It may do something to this nature in the as-built condition situation. And it looks like I accidentally clicked outside the slab there. No problem. I can select that tendon and click Trim Extend, and it'll bring it back to the slab edge. Now, I haven't specified tendon amounts yet. So if I just click this tendon, I can go over to the tendon specifications, and I can change the number of strands. I think this is a 25-foot span, so I'm going to need about 7 tendons, I think, for that. And then this one will assume about 13. Now, if I double click this tendon, we can actually see the shape and profile. And it has a similar Excel layout to the load combinations. And what you can do is you can quickly change, these CGSs like that. And we also have a tendon modifying tool that you can modify them in plan if you prefer. So I'm just going to keep the default profiles for now and leave it as that. Now, since this is an existing structure, there's probably going to be some rebar. So I'm going to assume that there is a bottom mesh of rebar. So I can quickly add that to this entire slab region by clicking the slab, and conveniently notice that rebar is the next option in our UI. So with the slab selected, I can use the mesh wizard option. And here we have a couple different options to choose from. I am going to assume I know the bar size and the spacing since this is as built. So I'll go ahead and change it to bar size. And I'm going to assume number 5s at 12 inches on center in each direction. And we'll click create. And the program gives us a wonderful notice that, hey, this was generated successfully. And we can see that here. We can click it and you'll notice that there's these control points that it has been mapped to this slab edge. All the way to that slab edge, that is. So now that we have a bottom mesh, we're probably going to have some rebar over the tops of these columns. At least I hope we have some rebar over the tops of these columns. And we can do that in a couple of different ways. You can add either banded or distributed bars. Typically for columns, we're going to assume banded. So I'll use that option here. And I'm going to draw some bars kind of over the top of this column here. And notice the dimensioning line right now, that's 11.5 feet. That's 12 feet. I think that'll be good. We'll go with something like that. And if I click this, I can change it to a top bar. And I can do other specifications such as the length and the bar size. Right now we're assuming a number 5. And we can just change the number of bars as well. Let's go ahead and say there's 10 number 5 bars on the top of this column. I can also show some of this rebar information. If I go to the display manager here and I toggle on the different elements, and then you can see what rebar we have added in here. Now this rebar is called base rebar, and that's because we added it. So that's just something to keep in mind. Now we can add some distributed rebar as well. So for example, this small cantilevered section might be a good candidate for that. So first we draw in the bar length. Let's assume it's going to be about there. And then we draw in the range that this rebar is going to be distributed about. So we'll say in that area. Now we can click this and we can change the information for this as well. For example, we're going to want this to be top bars. And notice right now, we have the input method set as number of bars, but perhaps we know that, yes, there is a distribution of bars in this area and we know the spacing. What we can do is we can actually change this to spacing, and we can specify the spacing. Let's say it's 12 inches on center again. And Builder will actually calculate the number of bars necessary for this area. You can see it changed it from 2 to 11. Now I'd probably want to add top rebar in this other area, but I'm going to not do that just so that I can show you how Builder is handling the different investigation versus design modes for if this is an existing structure or a new structure that we're designing. So going back up to our analysis or our UI, the next step would be our analysis tab. Now, since we're really trying to drill into this area of the design, I'm going to go ahead and skip ahead and set up what are called our support lines. What our support lines do is they create section cuts through our structure to take the finite element analysis results and display them for us for things such as moment, capacity, demands, deflections, and things of that nature. So I'm going to go ahead and use our dynamic support line editor. And this is a really useful tool in quickly setting up support lines. If I simply just draw this line through my columns, the program is smart enough to determine, and I have to press the C button to finish. The program is quick enough to, or smart enough to determine where these support line control points are supposed to be located. I paused this so I can actually select this and show you. So you can see the control points are on the columns there. This tendon's kind of overlapping it, so I apologize for that. And I could turn the tendon off real quick, actually, just by going over to tendon and toggling the tendon. Maybe I need to close that real quick. There we go. So going back to floor design, let's add another support line. I'm going to just draw this one in. No, we'll keep using our dynamic editor. It's a fun tool. So if this was a new project and we were designing it, we'd have to set up support lines for all of our columns in the X and Y direction. But we're more concerned about this area, and I'm just going to assume the X direction for the time being. Now, the way the support line is going to determine the section cuts is more or less based off a tributary. And what it's looking for is either an adjacent support line to determine the tributary area or a slab edge. So these are going to be okay in this area, but this support line has no idea where it needs to stop its tributary. And we can control that by using what's called a splitter. So if I just draw on a splitter right here, which is roughly halfway between those columns and that wall below it, this will force the section cuts to stop at that splitter. So if we generate the sections, we can see that now. So we have our loading, we have our PT, we have our base rebar. We also now have our design sections. These wouldn't have to be in here yet, but like I said, I'm just going to skip that step of having to come back and doing it later. I think it's time for us to get closer to actually analyzing the structure. So first we need to generate our mesh. Now we have a lot of extra features in here that will allow you to manipulate how the mesh is being generated, which can greatly impact runtime and real results. I'm just going to use the defaults for now. So we're going to save in mesh. You can see the mesh generated very quickly. We can toggle this off real quick. In fact, I'm going to turn off the loading as well because I don't want that shown, but I want to keep the rebar in there to show that this is actually being taken into account. So if we go back to our analysis tab, let's go ahead and execute the analysis. I'm going to go ahead and select a service load combination and a strength dead and live combination just to see a couple of the results. We'll click OK. And now the program is running through the FEM analysis for the entire slab and getting results for each of those load combinations. Now, again, we're really wanting to know what's going on in this area, not how the slab is acting as a whole. So we're going to go one step further, and we're going to go to our floor design tab once more. And this is where we have to pick whether this is a new structure or we're investigating. If it's a new structure, we're going to go ahead and design the sections. And what that's going to do is the program is going to add rebar necessary to meet the design requirements, assuming that your geometry is adequate. Obviously, if your slab's too small, no amount of rebar in the world is going to make it work. You'll figure that out when you try and design it, or you check your deflections to begin with and you realize that there's a problem there. The investigation option, on the other hand, is going to only take into account any rebar that we have added, and PT as well. And it's not going to add any more, which is what we want to do here. So we're going to go ahead and click Investigate Sections. So the program is integrating the FEM results over each one of these sections. What we can do is we can go over to our Analysis tab in our Results View window here. You can see I have the service total load combination selected. And I can go ahead and click on the Design Sections dropdown. We can see things such as deformation. For example, this is our span ratios here for deflection. We can see other things such as our moments, and even things like shear. So it's a powerful reporting tool as well. But really what we want to look at is the investigation. We want to see if this slab is actually going to be adequate for the additional loading that we added based on the as-built rebar and PT that is already existing in our structure. So what we can do is we can check this moment capacity with demand. And notice the green sections are everything that is okay. Our demand is this darker part of the graph. Our positive moment capacity is the green part, and our negative moment capacity is the blue part. And notice these pink sections over here, which are failing, and we're not too surprised about that since we didn't add any top rebar in this area. And something to note is notice that we see a jump in our moment capacity due to this bar right here. So obviously this is failing, and we would have to do some sort of retrofit or mitigation to resolve this. Now let's just go back and assume that this is a new building and we're designing it for the first time. Notice that I haven't changed anything. I'm going to use the FEM results that I had already determined, but this time I'm going to design the sections and pay attention closely to our moment capacity versus demand in this area when I design the sections. Notice how it jumped up. And that's because rebar is now being added in this area for this design. And you can see here the calculated amount of rebar, and the combination that is controlling is our service total, and that's 1.9 inches, square inches of rebar. It looks like there's a little bit of inadequacy here. This is probably just due to rebar rounding. We could add an additional bar and it would probably be okay at that point. So we've gone through how to investigate and design. One aspect that I skipped over, so let me go ahead and reset the display, is the ability to do punching shear. So we could set up our shear design options, and then we can also execute the punching shear check. So I'll go ahead and do that real quick. And it did it for all the strength combinations that I had analyzed for. So in this case, it was only one. So if we go back to our load combinations and go to strength, here's our strength combination. We'll select that. And going back to the analysis tab, you can see we now have a punching shear drop down. Here we can see things such as our stress check and which columns are okay and which ones need to be reinforced. We can also see things such as our stress ratios, as well as which combination is controlling. Actually, this is the critical section that is controlling. So this is critical section 1, which makes sense because it has the smallest area. We can also see the condition that the program is assuming these columns are taking. So for example, we have an end edge condition, a corner column, an interior column. You can see that in the legend up at the top left. We can also toggle the reinforcement that the program is recommending. So for example, here we can see that we're using stud rails based off of this legend. We're having 2 rails per side with a total of 8. And we have, I believe that's 3 studs at 3 inches. So 9 inches total rail length. Now, so far we've been working within single level mode within Builder, and you can identify that by looking at the top right here. This mode is extremely useful and powerful because it allows you to fine-tune the design on a floor by floor basis without having to analyze the entire building, which is going to save you time and effort. But this also means we can determine the design for a single level and then copy the rebar and PT to other levels in our structure. Even if they're not exactly the same, you can then copy the rebar and PT up and then manipulate it to fit the new floor plan. Or if it is a typical level that you're designing, it makes it really easy for you. Now, this brings me to the multi-level mode of Adapt Builder, which is right next to it. This mode is useful in determining the behavior of the building as an entire whole. This considers immediate shortening of columns relative to the stiffness and the resulting bending effects. These actions are not considered when you're looking at an individual level. You can do things such as check drift as well, or take into account P delta effects. And as we'll discuss in a moment, we can process a global model under different stiffness assumptions using what are called usage cases. Each unique set of reactions is stored and can be used for the design of different aspects of your building when you're using usage cases. This means there is absolutely no reason to export or import reactions between programs. Builder will keep all of them within the same model. So we're not going to use this model for a tutorial, the multi-level purpose. I could technically select this level and just go over to our Modify tab, and I could copy this up as many planes as I need, for example. But I have one that's already set up and has the geometry and loading. So let's go ahead and open that one real quick. And we're going to have an emphasis on designing the foundation at a later point. So I'm going to make sure that I have the multi-story functionality enabled, which is Adapt Edge. And I'm going to want to design my map foundation at some point, or at least get some results for it. So I'm going to enable Adapt Edge. We'll click OK. Now, the program is loading in the geometry, so give it 1 second. And let me change the view so you can see what we're working with. So I'll switch to multi-level mode, and I'll go to an isometric view. Now, notice that this structure is actually a mixed material of post-tensioning and RC only, which is really cool, and brings me to the point that Builder can handle this type of design, even if it's all in the same floor. If you have a floor that has RC only sections and PT only sections, it's smart enough to know when to design one over the other. Now, as I discussed, I could have created this model by copying a level up, or I could have imported additional CAD files like we did in the first step. But in this situation, one of the other ways that you could do this is by importing a Revit file. And Builder's really powerful in creating geometry from Revit because you can import a Revit file that is either an analytical Revit file or even a physical Revit file. And we're able to do a physical file because of the mesh generation that we had talked about a little bit earlier and the node shifting that is associated with that. Now, a really useful tool in Adapt Builder is our patented tributary load takedown feature. And this doesn't require you to run any FEM analysis. So I'll turn the tendons off using the default display button. And if we go over to loading, I can use our load takedown feature. Now, the tributaries on this are already created. So let me go ahead and delete them real quick. And I can show you how fast this tool actually is. So they're now gone. And if I click regenerate tributaries, the program is going to create the gym. I can't even say it fast enough. It's done. We already have tributaries and they're here. So we can also get loading for these tributaries as well. And notice we're not running any FEM analysis here. So if I recalculate loads, the program is now calculating loads for each of the tributaries and it's already done. So if I switch to a top-down view real quick, we navigate to our first level, for example. I'm going the wrong way. We need to switch to single level mode. you can see, let me close that window, go to analysis, and it looks like oh, there it is, load takedown, it's right in front of me. We can turn on the different aspects of our load takedown. We can turn on our tributary boundary. And notice that this is similar to probably what you had done in college, where you're breaking out your ruler and you're measuring the distance between the columns and getting the tributary for it. But Builder is powerful in that it can determine the tributary based off of the entire length of this wall, which is resulting in this sweeping motion of this tributary area, which is really cool. We can see things such as the tributary area, as well as the tributary loads. Let me back up. Notice that the tributary area is listed there, but so is the facade for this exterior column, which could be very useful in determining, hey, how many feet of facade do I have? And then I could determine, the loading that actually needs to be applied here. So perhaps now that you've done some preliminary sizing for your building using the patented tributary load takedown feature, it might now be a good point to really drill into this design and work towards getting results in a design based off of finite element analysis. So I'm going to go ahead and assume we have both gravity and lateral loading. So I'm going to go ahead and add some wind loads to this structure. And I can do that easily by using our wind load wizard. Here you can see different factors that we can input for a wind load, such as your topographic factors, directional factors, as well as what the primary wind direction is, your exposure heights. You can even set up user-defined wind loads, including torsional moments and things of that nature. Here you can see it looks like we have a couple of wind load cases in this model already. I'm going to go ahead and just click apply forces to update this existing wind load. I already applied these real quick, but here you can see I've now added windward and leeward line loads to each of these slabs. So if I kind of go into an isometric view, you can see each one of these for each of the slabs. So really powerful tool. I'm going to go ahead and reset the display again. We can do the same thing with our seismic load wizard. We have different factors such as your spectral acceleration, your response, your importance factors, and other coefficients. You can specify eccentricity as well and create several different load combinations if you wanted to, or you can even set up user-defined forces and things of that nature. I'm not going to do seismic this time around, but just wanted to let you know that it's there. We also have a general lateral load wizard. So this is where you can input user-defined loads based off of your geometry. So if you really wanted to do them by hand, you could do that and apply them here. So we have our lateral loading, we have our gravity, which was already in this model. Since I'm working towards the foundation, we're going to actually have to add a foundation to this model. So let's switch back to single level. I'm going to navigate to the ground level here. Let's change to top view so we can see this better. Here are all of our columns and walls coming down. I'm just going to assume one big mat foundation just to save us time since we've had a couple of audio and visual issues. So let me quickly just add in a slab region here. Now we're going to need to support this slab as well. So we're going to add a soil spring. I'm going to use an area spring. I'll just trace that over this. Like so. And if I select this, you can change the different parameters of the soil support condition. I'm going to leave the defaults here, but I'm going to want to assume that instead of this soil being able to take compression and tension, I'm going to assume it's compression only. Let's go back to multi-level mode and get an overall view of our building. So we're ready to start the design, the analysis and the design. But before we do that, it's now a good time to talk more about the usage cases, which I mentioned earlier. A usage case is another unique feature in Adapt Builder that allows us to adjust the stiffness of individual components or assume different cracking factors We can view the different usage cases and set them up by simply double-clicking any component. So for example, I'll click this slab. If I go over to stiffness modifiers, you can see a list of our different stiffness modifiers here. I can click edit usage and I can add and remove different ones here. Now, something important to note about this is these are unique per component. And so we have a lot of components in here. And this brings me to a new feature that we've added recently, and that's called our colorization tool. So if I go to colorize, I can say, for example, look at our slabs, and I can check the different usage cases for each of my slabs by selecting the different usage case here. I have arbitrarily named this one drift and this one strength design. You can see the drift usage case is all the same for all of our slabs, but the strength design, for example, is different. So we're assuming different stiffnesses for these different slabs. Now, it'd probably make more sense to have this one assume full stiffness since it's lower in our building. I'm just going to leave it as is. And you have full flexibility to change these as you want. You also can see them for columns as well and things of that nature. So what's really cool about this feature, the usage case feature within Builder, is that it will store the analytical reactions for the different usage cases all within the same model. So for example, I'm going to need to design my foundation for both gravity and lateral loads, but I might want to prevent my columns from participating in the lateral resisting system. I can obtain a solution for both situations simply by toggling the usage case and analyzing. Now, I'll have to analyze twice, but this saves me from having to use a gravity-specific model and a lateral-specific model. And as we all know, there's going to be change requests, and I don't know about you, but I'd prefer to just work with one model and only update that one model. It makes it much easier to keep track of those things. So that's usage cases. Let's go ahead and mesh our model. I'm going to go to our analysis tab. We're going to mesh. Now, notice we're in multi-level mode. And when I apply this mesh, it's going to apply it to everything globally since I am in global or multi-level mode. And it's going through each individual slab and adding the mesh. And I can toggle this off. Now, we're going to want to release our columns so that they do not participate in our lateral analysis here. So what I'm going to do, and I can do this multiple ways, is I could select all of my components. And here in our property grid, it's going to give a tally of everything that has been selected. And I can isolate by simply clicking and isolate selected type. And now that all of my columns are selected, I can go down to our releases, for example, and change the releases for the columns in their entirety. So I'm going to release the tops and bottoms from rotation. And that change has now been applied to every one of our columns. So let's go ahead and now analyze this structure. You can see we have several load combinations that have been included in here. I'm just going to pick one for the time being. I'm going to actually do a service level wind combination. You can see this includes self-weight, dead load, the pre-stressing forces, as well as our wind load here. And this is where I can actually apply the different stiffness case. So for example, I'm going to want to use drift in this case based off of, I arbitrarily named this, but this is the stiffness assumption I'm going to use. Now, before we click OK, we have the ability to tell the program how to interpret our soil support. We can either analyze the entire structure assuming compression springs as this soil, or we can substitute the soil as a fixed support. And this is ultimately just going to save you a bunch of time on your analysis. Maybe at the end is where you'd want to run this as the final check. But for the iterative process that you might be going through for the design, this is going to save you a bunch of time. So let's go ahead and click OK. So now the program is going through the entire building, including all of the self-weight, all of the dead load, and the wind load applied to the entire structure with this support condition and analyzing it and determining the results for us. So it should be done here in just a second. Notice that there were quite a bit of tendons and quite a bit of shell elements, so pretty quick. And there we have results for that load combination. And we could do things, let me go back, make sure it's selected. We have our wind combination there selected. We could do things such as check, for example, drift of columns. We can zoom in here and we can see what columns are acceptable based off of the maximum allowable we've specified, which is 0.25%. And it looks like the maximum is this 0.12%. We could change that by going into our display tab here, actually. And see, here's the drift maximum allowable value. And we could see other things as well. But we're more focused on the foundation at this point. So let me clear these results. And now that we have our lateral results, we're going to want to get the results for gravity. And we're going to want to unpin our columns now. So I'm going to go ahead and select the columns again real quick. Select isolated select type. And let's change the release for these columns. That's done. And now we're going to go back to execute analysis. And this time, I'm going to analyze for a gravity load combination. And in this case, I'm just going to pick a strength combination. We'll do strength dead and live. And I'm also going to switch to a different stiffness case. I'm going to keep the substitute compression springs on with fixed supports just to save on analysis time. We're going to click OK. Now the program is going through the analysis again with this new stiffness case and the new combination and factors and determining results. Now what's important to remember about this particularly is the previous run that we had with our lateral load combination, our wind load, is still saved within the model. We haven't lost that. And that's important because we're going to access that information later when we design our foundation. So let's go ahead and save the results. What we can do now is we can navigate to the bottom floor. I'm going to go to single level mode. Here's our foundation. What I can do is switch to top view, and we're going to execute the analysis one more time. Now, I'm going to select the two combinations that we had used, so strength dead and live. Let me find our service level wind combination. And now what's different about what we're doing here is we have the ability to include the different reactions from our previous analysis. So I'm going to include the lateral reactions and include the gravity reactions as well. But what's even more powerful about this is we can specify which case or stiffness case, usage case that we want to use as reaction. So in our wind case, we use the drift. So we're going to apply that stiffness case. But we're going to want to use our strength design usage case for our dead and live load. Here we have that. We're going to click OK. And now we're generating the results for our foundation based off of this, so to speak, envelope of different analyses. We'll click yes to save the results. And we could do things now such as set up support lines in our floor design tab and go ahead and start running through the design of this. We could also check things globally from the FEM analysis, such as our soil pressures. So if I go under stresses, we can see our soil pressure here and things of this nature as well. So I think this brief overview just shows just how powerful and flexible Builder truly is. And now I'd like to show you a real life project where our users at Lyra have leveraged Adapt Builder to design an incredible project. So this particular project is the Vagelos Education Center at Columbia University. It has won several awards, including the Buildings Award of Merit from PTI, the Excellence in Structural Engineering from NCSEA, and the Award for Innovative Design from ACI. To put it lightly, this incredible structure has very complex geometry. The main structural challenge was to determine vertical load paths while adhering to spatial requirements. Adapt Builder's multi-story features were essential in understanding the load sharing effects at the cantilevered slabs, allowing them to be designed to work together. The software was also used to coordinate deflections in the all-glass facade. In fact, the picture in the lower right shows some of the Adapt Builder output that was used for this deflection coordination. Let's now talk about some of the features and enhancements in Adapt Builder version 20 that will improve your overall experience. First, we have now implemented cloud licensing. This flexible and scalable licensing setup allows you to easily access your licenses anywhere and is billed annually. The customer portal on our website allows you to manage these licenses, such as grant or remove access to your users, usage monitoring, as well as pay your annual renewal. For analysis and design, we brought back column and middle strips while incorporating them into our dynamic support line editor for the ease of use and speed in your modeling process. I had reviewed that dynamic support line editor when we first did the investigation and design in single level mode. It's a very powerful tool. Our punching shear checks regarding openings have been greatly improved as well, including reduction in critical section, multiple opening detection, manual control over the design, and more. You also now have the ability to set up user-defined modulus of rupture. Concerning the user interface and general workflow enhancements, our new colorization feature provides efficient filtering and sorting of components based on properties and attributes. Coupling this with the new property grid enables you to make changes in a smooth and efficient manner. Our compiled report improvements now removes the manual setup that was previously necessary for individual graphical reports and several of the tabular reports. Now, all of your reports can be set up in one convenient location and all in one shot. Lastly, we've included the ACI 2019 design code, which has updates to reinforcement strain limits, updates to one-way shear strength, new size effect factor for shear and two-way slabs, and many more. In fact, we have another webinar coming up on Wednesday, February 24th at 2 p.m. Eastern Time, where we will discuss and demonstrate these ACI code changes and updates for both the RISA and ADAPT products. You can register by visiting risa.com/webinars, or if you're on our marketing list, you'll be receiving an email with a registration link. In closing, we've learned how easy it is to leverage the robust and flexible features that Adapt Builder has to offer for the design and investigation of post-tension concrete structures, both in single-level and multi-level scenarios. I demonstrated how all of these situations can be handled by Adapt Builder within a single model, backed by the powerful modeling and design tools, which results in minimal effort. I appreciate everyone's attention during this brief highlight of Adapt Builder's key features. If you're wanting to learn more about Adapt Builder or more about the other products we have to offer, I invite you to check out our YouTube pages. You can also email us at adaptsales@risa.com. We'll be more than happy to provide additional information and answer any questions you have. Thank you so much for joining us, and we'll see you next time.